Hello friends, this is Dr. Hemchand Kothari from We Research Academy. Friends, in this lecture we are going to discuss the standard deviation in continuous series. In previous lecture we studied standard deviation in discrete series and individual series. So this lecture will be in continuous series. Okay. So the link of the previous lectures I have given in description box. So you please just get it from there. So let's start. So we have a question here. We are given class interval. This is class interval. So under class interval, we are having the intervals from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60. Last one is 60 to 70. Okay. So these are our class intervals or simply groups. Next column we are given, these are the frequencies of these class intervals. These are 3, 8, 10, 3, 8, 10, then 6, 15, 8, 6, 15, 8 and 5. So friend, this is the question and we have to get the answer out of it as standard deviation. So here we are calculating the standard deviation by direct method. Okay, so in direct method what we need mean first, and for mean we need multiplication of f and x. Okay, so for this multiplication we don't have x here. Okay, so what we need first, we need x. Okay, then only we will apply this f with this x. Okay, so this x is nothing but a mid value. Okay, mid value here means lower limit plus upper limit upon 2, right? So this becomes 0 plus 10 by 2 equal to 5. Okay, this we will follow in for each of the class interval that we usually follow while calculating the mean and other calculations as well. So whenever we need to calculate this x or mid value from the group, we follow this one. For second one, 10 plus 20 divided by 2, this will become 15. And if we add 10 in each succeeding value, this will give us 25. Okay, 25, then 35, then 45, 55 and 65. So you do not need to calculate this every time, as we know the class interval is of 10. So this is easy to calculate this mid value by getting the first mid value. We will add 10 on each succeeding axis, right? So once this x is calculated, what we need? We need to calculate the fx. For calculating mean value, we need fx, right? So fx is nothing, it is just the multiplication of these two columns here, f multiplied by x. 3 multiplied by 5, this is 15. 8 multiplied by 15, 120. 25 multiplied by 10, 250. 35 by 6, it is 210. Okay, 210. 6 5 is 30, 6 3 is 18 plus 3, 28. And 15 into 45, so this gives you 675. 8 into 55 gives you 8 5 is 40, 8 5 is 44, 440, right? Next last gives you 5 5 is 25, 5 6 is 30 plus 2, 32, 325, right? So once you do this and get the fx, then you need to calculate mean here. Okay, so mean is what? By direct method, mean is sigma fx upon sigma f, or simply n. Sigma f is also known as n. So here we need to sum all these fx's, and this is known as sigma fx, and this value is 2035. Okay, so if you just get it total, this will give you 2035, 2035. Okay, the summation of all these fx's. Okay, put these two value, and the sigma f we are having, these are 55. If you get it total, this will produce you 55. This is sigma f. Okay, so put these value in formula, you get 2035 by 55. Okay, so this gives you answer equal to 37. So your mean becomes 37. So once the mean is calculated, the next step is to calculate mean deviation, deviation from mean. Okay, so this is simply small x. Okay, this is small x, or simply deviation, or you can say dx, right? So this is small x equal to x minus x bar, right? So x minus x bar you need, right? So this is the x, and this one is the mean or x bar. So 5 minus 37, it gives you minus 22. 37, this gives you minus 32. Minus 32. 15 minus, you just reduce 10 here, again 10 here, again 10 here. This is in positive. 45 minus 37, this will give you, 45 minus 37 will give you 8. Okay, 8. Then 55 minus, again add, these are the plus 1. 8, 18 and 28. Okay, right? So these are your small x's, or simply deviation from the mean, right? What next you need? You need square of this x. You need square of this x, small x square. Okay, right? So 32 square gives you 1024. You just 22 square, square of 22 gives you, this is 484. Then 144. Then 4. Then 64. Then 324. And the last one is 784. Okay. So these are the squared value of these deviations, right? In the last column we need, in the last column we need f x square. Okay. Last column we need f x square. Frequency multiplied by this deviation square, the square of deviation, f x square. Okay, f multiplied by x square. Okay, so we are having this column f frequency, and x square is this one. So 3 into 1024, we have 3072. 8 into 484, we have 3872. 3872. Okay, 8 into 484. 10 into 144, we have 1440. Right? 6 into 4, we have 24. 15 into 64, we have 960. 960. 8 into 324, we have 2592. Okay, and last one, 5 into 784, we have we need next? Okay. We need a formula to calculate standard deviation. This is same as we applied in discrete series. Okay, because in this discrete series the question is same, but one thing is not there, that is the class interval. In discrete series we are given frequency with the the axis. Okay, here axes are not given, intervals are given. We have to find out the axis as mid value by applying this lower limit plus upper limit by 2, right? So next we need a formula. Formula is that I am just mentioning here, that is same as applied in direct discrete method. Okay, so let's solve this one. We need a formula. Formula is here square root of sigma fx square upon sigma f or n, right? Okay, so formula of standard deviation, this is denoted by small sigma, is equal to square root of sigma f x square upon sigma f, or this is also known as n. Okay, sometimes. And in some statistical inferences, this is n minus 1. We are not applying this n minus 1 here. Okay, so this will give us like a different answer here, but it will be just negligible. Okay, here we are not applying this minus 1, we are just solving it by only n or sigma f. But in statistical inferences, it is minus 1 as a parameter. Okay, we have to just subtract it as a degree of freedom, or you can say, or as a parameter, right? So now equal to, just put all values which are required in formula, summation of fx square. So this summation is 15880. If you get total of this one, this will give you 15880. Sigma fx square is 15880, and sigma f we are having 55 here. Sigma f we have 55. Okay, so 15880 divided by frequencies. Okay, so this gives us square root of 288.73 approximately. Okay, and if you get this root of this value, you will get 16.99. Okay, so if you find the square root of this value, this will give you 16.99. Okay, so this is our standard deviation of this question, 16.99, right? So sometimes it is also asked in examination that you have to just calculate coefficient of variance, CV. Okay, as a part of question it will be asked either of 2 marks or 1 marks. Okay, generally it is asked in 2 marks. Okay, let us say total question is of 10 marks, so it will be a 10, 8 plus 2. 2 marks will be for the coefficient of variation. Okay, so this coefficient of variation is also asked in many examination as a multiple answer type question. So option type question, where you will be asked what is the formula of coefficient of variation, right? So coefficient of variation or CV is simply standard deviation divided by mean value. Okay, so when we divide this standard deviation by mean, it gives you coefficient of variation. Coefficient of variation is the relative measure of the deviation or standard deviation. Relative error means this deviation in relation to the mean. So this helps us to find out more means which frequency or a group has more volatility in comparison to the mean. Okay, so this is very important while decision making or making any inference about the statistical data. Okay, so we have both the value here. Both here means standard deviation we are having this one 16.99 and mean value we are having this 37. Okay, so if you divide this 16.99 with 37, it gives you answer. It gives you answer how much? 0.49. Okay, sorry, this is 459. Sorry, 459 or 46 you can say approximately. So this is 0.459. Okay, so friend, this is the procedure of finding standard deviation, which is most important in many of the examination. And we have also to find out many times this coefficient of variation. So friend, thank you very much for watching this video. If you find this video valuable for you or knowledgeable for you, you please just share it, like it. And if you have not just subscribed this channel so far, you please just subscribe it and also press the bell icon so that you will get the notification of the future videos, right? So thank you very much. Have a nice day ahead. God bless you.